Mars has a moon that rises in the west, sets in the east, crosses the sky twice a day, and is slowly spiraling toward its own destruction. The moon is Phobos, and it orbits closer to its planet than any other moon in the solar system relative to that planet's size, only about 3,700 miles above the Martian surface, roughly a tenth of the distance between our own moon and Earth. It completes a full orbit in just 7 hours and 39 minutes, faster than Mars itself rotates on its axis. That's why, from the surface of Mars, Phobos appears to rise in the west and race visibly across the sky before setting in the east, sometimes crossing twice in a single Martian day. Most moons, including our own, slowly drift farther from their planet over time, gaining energy from tidal interactions. Phobos does the opposite. Because it orbits below the altitude where its speed would match Mars's rotation, a threshold astronomers call the synchronous orbit, Mars's gravity is gradually dragging it inward rather than pushing it outward. Scientists tracking its orbit closely over decades have measured Phobos spiraling closer to Mars by roughly 2 centimeters every year, a slow but completely relentless and well-documented process. By comparison, our own moon drifts away from Earth by a few centimeters every year in the opposite direction, showing just how differently orbital tides can play out depending on distance. At that rate, researchers estimate Phobos has somewhere between 30 and 50 million years left before its orbit becomes unsustainable. Long before it could actually crash into the Martian surface, it will cross what's known as the Roche limit, the distance at which a planet's gravity becomes strong enough to overpower the object's own structural integrity through tidal stress. Phobos will most likely be torn apart at that point, its debris scattering into a faint ring around Mars, before what remains eventually rains down onto the planet below. Phobos's origin is still genuinely debated among planetary scientists. It could be a captured asteroid, gravitationally pulled into orbit long ago from the nearby asteroid belt, or it might have formed in place from debris left behind after an ancient impact on Mars itself, similar to how our own moon is thought to have formed. Japan's space agency plans to send a spacecraft called MMX to Phobos to collect a physical surface sample and bring it back to Earth, a mission expected to finally help settle exactly where this doomed little moon actually came from. Deimos, the other Martian moon, is small and far enough away that it faces a very different fate, slowly drifting outward instead of spiraling in. Subscribe for more small worlds living on borrowed time.